Okay, I learned something last period. I learned that you don't want to teach math with your phone in your pocket while leaning on this table. I called 911.
You did not.
I did. I was like, what the heck's going on? Okay, because it's making this really weird noise, which my phone's, silent, on silent. And I was like, okay, that's really weird. So I just clicked it off, and somebody said, oh, it's 911. And I was like, sure enough, they called right back. So I just said, no, this is not an emergency, because, of course, they have to verify it's not an emergency, blah, blah, blah.
Did you say I asked you?
Yeah.
Did you say I got dialed?
No, I said I'm teaching math at Homestead High School. There's no emergency. Because if they know it's Homestead, or at school, they want to make sure there's not a problem. So some student helped me shut that setting off so that I won't have to worry about that anymore. So anyway, I need you to remind me. No. I got that part down, I think. What's the shape of y equals the positive square root of x? Kind of generically speaking. Well, I'm gonna just kind of review with you because we might be all the way through 13, looking at 14. Is that right? Okay. The ones that I think that was last period, so I might have to. Okay. So the positive square root of x should look something like this. All right. Here's my next question for you. What do you think? The negative square root of x looks like? The same thing but down. Excellent decision. Okay. What's the domain of the blue function? What is the domain? What kind of values are you able to put into a square root function? Look at the picture. Remember we talked about how domain, you take all the values, you just smash the whole graph onto the x-axis and tell me. Yeah? What do you think? Okay. Take a few seconds to talk to your neighbor about math-related topics, not what you're talking about, and then see if you can help me understand the domain of this. What's the domain? I've got a vote for 0 to infinity. Does it include 0? Yes. Okay. Now, that type of notation that I was just quoted, some of you are comfortable with and some of you are not. It's called interval notation. You do not have to write it like that if that's not what you are used to. If you would rather say x's have to be greater than or equal to 0, I'm okay with that too. You definitely have to start at 0 and you have to have everything bigger than that. What are noticeably missing from the domain? What kind of numbers can you not put in that function? Negative numbers. Now, in a little bit, we're going to get to the cube root. Now, a cube root function kind of looks like the blue one a little bit. Now, can you take the cube root of a negative number? Does anybody know if you can take the cube root of, say, -8? Is there a number in the universe when you multiply it times itself 3 times gives you -8? Is this possible? A number times itself 3 times which gets you -8. Yes. -2. What this is telling me is that a cube root can handle negatives. And the other part on it, and so that makes sense because -8 produces -2. That would be like -8 and a -2. So we get this opposite looking piece. So that green one, the entire green one, is the cube root. Can you tell me what the domain of the green one is? If the blue one was from 0 or greater than or equal to 0, what's the green one? If you're used to the interval notation, you would say negative infinity to infinity. Some of you are used to the all real number sign. Some of you would say something like this, all real numbers. That's all real numbers, not all real hashtags. All right, now we talked about this one a little bit. Can you remind me? I do not see a shift in this at all. I know we already worked through this one, but I just kind of want to remind ourselves from last week. I don't see a shift. There's no left and right. There's no up and down. But there is something going on right here. What is that thing doing to the graph? That number happens to be a positive number, and it happens to be larger than 1. So what is it doing to the graph? If this is a good old square root function, what is this 3 doing to the graph? Is it vertically stretching or vertically shrinking the graph? It is vertically stretching the graph. In other words, it's taking these points and pushing them away from the x-axis. So that is a vertical stretch. And it's all because that number is greater than 1. So tell me what you think would happen if that number was less than 1. Suppose it was 0.5. What do you think will happen? It's going to be a shrink, isn't it? A vertical shrink. So if it was a vertical shrink, let's say it was something like y equals 0.5 times the square root of x, that would be a graph that would be like this. It would be shrinking. It would be pushing it down towards the x-axis. But we've got a vertical stretch going on here, and I believe when we looked at this, now the dumb thing about this particular question is, we knew from the beginning there was no shift. Which two choices does that immediately eliminate? The first one, and which other one? The last one. There's shifting going on in both of those, so this wasn't even really a difficult choice. But we can see in the picture that the values were stretched away from the x-axis. That's what the 3 was doing. Okay. You know what? I need to go back here to this one right here. We already answered question 12. It was a square root. There was x plus 5. But what I'd like you to do right now on question 12 is I would like you to give me the equation of answer choice B. Answer choice B. It is not the correct answer for question 12, but I want you to give me the equation for answer choice B. Alright? And I do want you to compare with your neighbor. Ask me if you need help. Look at answer choice B and come up with that. Okay, which way do you see in the picture it moved? Up, down, left, or right? This is down 5 units. So you needed to write an equation which said down 5 units. The shift has to be on the outside of the radical. If you put it on the inside of the radical, suppose you wrote this, y equals the square root of x minus 5. Which way did you think it was shifting? Or which way are you telling me it's shifting? No, remember we said if it's inside the radical, it's backwards of your common sense. So this equation is a right shift. Okay, go down to letter C. Letter C. It's important that you add these notes. Even though these are not the right answers, it's important that you add these notes into your notes because you're taking a test and using the notes to help you. So what's this one going to look like? Y equals, is this correct? Which one of these? Top or bottom? It is the bottom one that's saying shift up 5 units. What is choice D? Y equals? Is it a big square root or a little square root? Big. Okay, what goes in there? X minus 5, that's true. That's right 5 units. Right 5 units. Okay, ask your question if you're confused. Which part? Okay. Okay. So do you notice how the x plus 5 is inside the radical? Every time we do things that are inside, so for instance, this is another one that's an absolute value, but it's inside. Here's a parabola, but it's inside. Every one of these is taking the original shape and moving it left 5 units. Now, we talked about why that's the truth, and we talked about how what's really going on, if you want it to stay the same, is you have to put in values to continue to get a 0. What number would you have to put in here to get a 0? Now, if I put a 0 in, I would get negative 5. Now watch what you just said. In order to get a 0, I would have to put in negative 5. In other words, okay. So that's, I know it kind of looks backwards under common sense when you see that x plus 5 in the radical or inside the parabola or inside the absolute value bars, but you got to get it in your mind that you're shifting left. Now, shut the folder on my is that big of a deal? Which evidently it is. Okay. The ones on the outside of the radicals, on the outside of the squares, on the outside of the absolute value bars, they follow your common sense. So when you see that plus 5 on the outside, you know it goes up. You see the minus 5 on the outside, you know it slides down. It's the part inside the radical or inside there that trips kids up all the time. And so I constantly am saying, it's the opposite of what you think on the inside, exactly what you think on the outside. Okay. There are 3 things going on here that I need you to pay attention to in question 14. First of all, what kind of shift are we doing right here with the x plus 1? Is that left or right? That is left, 1 unit. Okay. What about the minus 3 on the outside? That is down. That does follow our common sense since it's the vertical direction. This number that's out in front, is it positive or negative? It is positive. That's important to you. Something else that's important to you is that it is less than 1. Now, if it's less than 1, what's happening there? Is that a vertical stretch or a vertical shrink? That is a shrink. Okay? The values are going to get closer to the x-axis. Okay? Because this is a positive number right here, can you give me 2 answer choices which are absolutely ridiculous? C and D. Look how they're both upside down. Both of them are based on the negative square root. So they do not apply to this problem. So I need to then look at choice A and B. I need something that has been moved left 1, it's been moved down 3, and it's closer to, or it's been shrunk in the vertical direction. Isn't there one very obvious answer? I heard it over here on my left. B. If you take a look at the picture, you can see that it went left 1, down 3, and if you take a look at it, doesn't it look like it got moved closer to the x-axis, so it had that shrink involved? Now, it's going to be your job to come up with an equation for answer choice A. There are a couple things that you and I are going to agree upon and have to agree upon. It looks as though it's gone to the left 3 units. It also looks like it's gone up 1 unit. So every one of us should agree on that. The part that goes in front of the radical, I want to see what you put in there. How do we make it go left 3? What do I put under the radical for left 3? Plus 3. What do I put on the outside to make it go up 1? Plus 1. Now you make a decision on what you're putting in that blank in front of it. I want to see what you decide. There are more than one option that I'm going to say yes. Stretching away from less than 1. When I say less than 1, I still mean target. It's shrinking it towards that center line. Okay. If it's negative, it's going to flip down like this, which is what answer choice D on that. That's why we rule them out here, because we knew it wasn't. Yeah, there is. I'm not. What I'm looking for when I'm walking around the room. Sure, we would have to take a coordinate and plug it in and make sure we can find the exact value. We can do that. I'm not really trying to zero in on that. I'm guessing that this could be positive. It could be. I think this is probably, I'm guessing it's bigger than that. It looks like it's been pushed away. So, that's a good question.
Okay, so
Okay. What kind of number needs to go over here? What kind of number needs to go in front? I'm not going to argue if you put 2 or 3 or 10 or 7 or 19. What are the important things that I'm looking for in that number? It's got to be positive because you're going up. You're following the up pattern. Now, why do I think it has to be larger than 1? Because it's not close to this. It looks like it's being stretched, as you can see from this one over here, where it looks like we shrunk it down, which is why that was the answer choice for 14, because of the 1/2 causing it to shrink in the vertical direction. Okay, give me, let's see here, a second. I'm going to zoom in here on letter choice D. Okay, y equals, okay, it looks like we went left 3 and down 1. Okay, so how do I say left 3? What do I put under the radical for left 3? X plus 3. What do I put on the outside of the radical for down 1? Minus 1. Okay, now, what possible number do you think I should be thinking of? Give me an example of a number that you think is a realistic choice for that in front of the y, or front of the radical. Negative 1/2 is a vote that I have here in the back. Do you think that that is negative? I definitely would agree with the negative. Do you think the 1/2, because it's being shrunk in the vertical direction, do you think this is a good choice or a bad choice? I think it's a good choice too. Nicely done. Okay, when you look at that, the negative is what's causing that to flip over. Okay, the only thing I really want to look at this question for is I want you to look at this equation right here and tell me what you notice about that right there. Do you think this is a vertical stretch or a vertical shrink? Why do you think stretch? Because it's way bigger than 1. Right? It's a lot bigger than 1. So it is definitely a vertical stretch. Now, I'm also noticing in this graph that there is no shifting. There's no pluses and minuses. We're not going left, right, up, or down at all. So which graph, if there's no shifting, then I am immediately getting rid of those two choices. Because we're not moving this graph left or up. So if you know it's a vertical stretch, which one does it have to be? B. I guess I gave it away. That's really what I wanted you to see in that particular question. We won't do the rest of that one. Okay, question 16. We talked about the cube root function. We talked about how the basic cube root function has a positive part, and it also has a negative part, unlike the square root, because it can handle all real numbers. So, this minus 5, what's it doing to the graph? It shifts it down 5 units. That's true. Which one of those is the correct answer? A, B, or C? It is choice C. That's the only one that took the cube root function and shifted it down 5 units. We have one last question, and I kind of want to go through this quickly since we're running out of time. What's the x plus 2 doing to the graph? Left 2. The minus 1. Down 1. This is a positive number. Okay? So we definitely know that it's going to be based upon the positive square root. It is also greater than 1. What did you say? That is a vertical stretch because it's larger than 1. Okay? So, put them all together. And which one do you think it is? It's definitely not A or B because they have a negative multiplier. And it is choice D. That is right. A vertical stretch. And it went left. Now, there's more to that question. They asked me about the domain and the range, so let me zero in and you tell me out loud before we leave here what you think the domain is. If you smash it all onto the x-axis, how much of the x-axis would you have? -2 to infinity. Thanks for not talking over the top of me like rude people. Hey, my time. Thanks. If you want to say greater than or equal to -2, that's all right as well. The range. What if you push all of these onto the y-axis? What's the range? -1 to infinity. That is true. Or for those of you, y is greater than or equal to -1. That would be my range, and my domain was this.